Hi guys, welcome to lecture 2 of uh, unit 10 on air pollution. We're in chapter 15. Hopefully you looked through the first lecture and have that chart all filled in that go through the big 6 criterion pollutants and the human health and environmental impacts. We have just a couple more lectures and I'm going to cover acid precipitation and solutions all in one. So you'll get the rest of that content. Um, so we're going to look at the formation of tropospheric ozone. Um, that term is used often synonymously with photochemical smog. Technically, the photochemical smog is this big sort of soup of mixtures. The main ingredient in that soup is ozone. This is kind of a tough topic and something that's been pretty heavily assessed in the past. So you may want to kind of look through this more than once, or you can get out your book and go over it. And certainly if you have any questions, make a note of them and we'll address those in our next online chat. So if you were watching the videos by the College Board for the rest of units 8 and 9, you saw my colleague, Dr. Scott Sowell, talk about the good ozone that's up in the stratosphere. That is in unit 9, and so we don't need to worry about stratospheric ozone depletion. Never on this exam should you say anything about ozone being depleted. What we're looking at, and obviously that ozone up in the stratosphere is the good ozone. I talked about that a little bit in the first lecture with the layers of the atmosphere. In this one, we're looking at the formation of ground level ozone, or tropospheric ozone. This is the bad ozone that forms completely as a result of human interactions. And there's two big concerns about tropospheric ozone. A, it's a really, really harmful, strong oxidizing agent that can actually damage my lungs. And B, it's a greenhouse gas, and it's a pretty potent greenhouse gas. So here's the formula for how tropospheric ozone forms. The first thing I need is sunlight, because this is a photochemical process. And the sunlight breaks apart these atoms of NOx. So remember from lecture 1 that NOx is emitted from burning gasoline. I also have these VOCs, these volatile organic chemicals. These are organic compounds, hydrocarbons that really easily evaporate. So think of like an alcohol that you spill on the table and it evaporates into the air. The reason we're concerned about these is anytime anything is going to rapidly evaporate and become a molecule in the air, I can now breathe it in and it can be a harmful pollutant. So I've got these VOCs, I've got this NOx, I've got sunlight, and these chemicals all react to create ozone, to create tropospheric ozone. So let's dig a little deeper into this process. What happens is ultraviolet light from the sun, that is the ability to break chemical bonds, breaks off an oxygen from this NOx molecule. Here's NO2, the NOx molecule. This diagram doesn't show it, and to be honest, you don't need to dig that deep into the weeds of the process. But technically, like this kind of looks like a molecule of methane to me. That methane oxidizes in the atmosphere, releasing carbon dioxide and CO2. So when you're like, well, I don't understand, there's no oxygen here. I get that this sunlight splits this oxygen off of NOx, but what happens then is that can combine with molecular oxygen in the atmosphere or some of the oxygen from these VOCs, and together they sort of bake this the formation of this compound of ozone, O3. It causes severe respiratory discomfort, but it can also damage lung tissue. So for example, when the Olympic Games were in Beijing, and there was really bad photochemical smog there, a lot of long distance athletes just said, I'm not even going to compete in my event because I don't want to actually damage my lungs from breathing that air. Just like it can damage my lung tissue, it can damage plant tissue and disrupt rates of photosynthesis. And here's an image of before and after, 1968 to 2005. The reason that we greatly reduced ozone emission or ozone formation is because we reduced NOx. And if I can reduce the concentration of NOx, I'm going to reduce the amount of ozone that forms. Remember, this molecule does not exist as a naturally existing compound in the troposphere. And because of the nature of a photochemical reaction, it's photochemical smog is always going to be more severe in areas where I have a lot of cars, because it's that NOx emission from gasoline. Areas that are really sunny, because I got to have that sunlight to split that molecule of NOx. And areas that are warm, because all chemical reactions happen faster in a warm environment. So all of these things together indicate that photochemical smog, i.e. ozone, is going to be much worse in a large urban area. So we're going to look at a couple example questions. I'm going to do 2 multiple choice. I think I have 2 of them here with you together. And then I'm going to leave you with a short FRQ prompt that you can write on your own. And then you can just stop the video before the answers display. So nitrogen oxide is produced early in the day. Ozone concentrations peak in the afternoon and are higher in the summer because ozone is produced by chemical reactions between oxygen and sunlight. Which of the following best explains the pattern of NO concentration? I'll give you a second to think about that one. And you should have picked out that letter D is the correct answer. NOx is a primary pollutant. It's emitted directly from the combustion of gasoline. Tropospheric ozone is a secondary pollutant. No combustion process releases ozone. And as I look at the graph here, during early rush hour traffic, like in Los Angeles, I have this high concentration of first NO, then O2. I don't care, it's NOx. There's my hydrocarbons, my VOCs, and shortly after these peak, that chemical reaction occurs, and then I get that rise in ozone concentration. Oh, I'm lied. I did only have one example of a multiple choice. So here's your FRQ. The next 2 slides go through the answers to all of that. So just stop the video. Try to do those simple 3 prompts. Super good practice for the national exam. And then I will see you in the next video on thermal inversions. Have a great day, guys.